Now we're going to talk about potential energy. When we move objects around in the gravitational field, like, say, pick them up, we do work against gravity. So that stores energy in the field. Because it's stored energy, that really truly is the meaning of potential energy. So the general expression for what we're going to get here, it comes from the universal law of gravitation, and really it comes from the fact that at infinity there's no force, and so you're actually doing work against gravity to bring a mass to a given point in space. It's a little complicated, and I have a video after this to show you. But really, that's all to explain a negative sign in the equation. So, do we remember our potential energy due to gravity from the last unit? So, this worked on Earth, where we knew what G was. So, let's use a more generic force due to gravity than a mass times acceleration. So, here, force due to gravity times a distance, okay? And then I have my universal gravitation law. And really, if I'm talking about, say, two planets, it's not really a height anymore, right? Now I have to look at the center of masses. So here, r is the distance between the two centers of mass. So I've plugged that in for h. If I have an h in the numerator if I have r in the numerator and r squared in the denominator, the exponent in the denominator cancels, and I'm left with g m1 m2 over r. But remember that negative sign? So here's the equation that's on your AP equation sheet. So the biggest difficulty with this one is remembering that it's exactly the same as the universal law of gravitation, except it's not r squared in the bottom.